2.
Hello?
Yes, our teacher, she's she's in already. Don't worry.
Sorry about that.
It's okay. You're welcome back.
Thank you. Okay, so I was still asking the valency of a sulfide.
It's 2.
Thank you. So we have iron, we said it's 2. Then for sulfide, you said it's also a 2. So what comes next? Can someone guide me what we can do here?
Interchange the values.
We exchange the values.
Yes, we interchange the valencies.
Exchange the valences. Thank you. So we'll have and the 2 there, then a sulfide and the 2 there. What happens when we have divisible valences or similar valences?
Reduce
They cancel out, one here and one there, which gives us iron 2. Yes, we reduce them to get the smallest ratio. Thank you. So it will come up with our compound as iron 2 sulfide. So that is what is happening here. We have the iron reacting with the sulfur to give us the iron 2 sulfide. And then the arrow means to give or to, that means iron is reacting with sulfur. And the arrow means this is our product, the iron 2 sulfide. So in that case, we have our iron reacting with sulfur to give us
and sulfide.
I am sorry, I hope that doesn't continue for the rest of the lesson. Okay, we have, therefore the above reaction can be interpreted as iron reacts with sulfur to form iron 2 sulfide. And we have some examples here. They are telling us to write
Question.
that. Yes, please go ahead.
If we had finished exchanging both their valences on both sides and then we divided both sides by 2 and then got 1, why is it that we still have iron 2 sulfide and yet we left it as, Fe or not?
Oh.
Excuse me, teacher, you're breaking.
Share break.
To specify what kind And I answered your question before I went off? Or do I
No.
need to re-explain?
No.
You are breaking.
Answer the
You are
question.
Okay, I was saying
Teacher,
that
you're breaking.
in this case, we form iron 2 sulfide. Reason being iron 2 is giving us this 2 here is giving us, you're not hearing me. Are you able to hear me now?
Yes.
Now?
Yes.
Here is giving us the valency to which iron belongs, because we know that we have iron 2 and iron 3. So if we have iron 2 and iron 3, we need to understand which valency are we dealing with. Otherwise, you will wonder, am I using okay, I was saying
Excuse me, teacher
that
Martha.
if we have an element that has, yes, Mr. Angelo.
Can I try sharing, then you explain and we see if your network can get better?
Yes, maybe.
Let's try it and
Thank you.
you tell me what to do and where to go.
All right, thank you.
I think you're there.
Yes. So I was still explaining to Johan that if you have an element that has 2 or more valencies, like for example, iron has a valency of 3 and a valency of 2. So you have to specify what valency you are dealing with. So in this case, we are dealing with iron 2. That is why we have iron 2 sulfide. So it does not disappear because we are specifying the valency to which that iron belongs. I don't know if I've answered you. Johan, is your question answered?
Yes, thank you, teacher.
You're welcome. Okay, so we're moving to the examples. And can I have someone read for us example, the instruction and example number 1? Yes, Shona.
Write the chemical equations from the following word equations. 1. Hydrogen plus oxygen gives us water.
Okay, thank you, Shona. I'll request one of the girls to help us tell us what we are going to do in this case. You can direct as Mr. Angela illustrates on the screen. Basing on what we've done with iron 2 sulfide. Yes, Shonila. You can then.
Which I'm going to try.
Yes. Of course, thank you for trying, but I just want to guide us through using your example. Tronella, are you still there? Okay, let's hear from Tongo.
Teacher, me, I think I think since we know how hydrogen is H, so H plus oxygen, that is O.
So it write valence down. Oxygen has a valence of 6. Before we write that, oxygen has a valence of 6. And then to make the equation equal on both sides, you have to add the 2 to the H. The oxygen does have 6 valence.
Kadu, are you meaning what I've written down?
No, the oxygen after the addition sign should have valence down.
So there should be 2 here.
No, on the other oxygen.
Oh, okay. Let me write it down. In like this.
And then, yes, then for the H, we could add another 2.
Your contributions, but one thing you have to take into consideration, we know that hydrogen and oxygen, hydrogen has some another signs when I said diatomic, that means they exist as diatomic molecules. They have 2 atoms in 1 molecule. And when you're writing hydrogen, its chemical symbol is H2. And then for oxygen, its chemical symbol is O2. So you should have that at the back of your mind, that most of these gases exist as gas. When you're writing chemical equations, as we did for the iron and sulfur, we write hydrogen plus oxygen, giving us water. So Tronella gave us the chemical formula of water. So it gives us water. So we have an equation where we have our reactants as hydrogen and oxygen and our product as water. Yes, Johanna, your hand is up. You have a question?
Yes. So, teacher, when we're writing that as independent elements, so we have to include that too, but we have to ignore it when we're coming up with chemical formula.
Okay, I hope I picked your question well, Johanna. When you're writing chemical formulas of specific elements, you have to know how they exist. Do they exist as monoatomic, depending on what kind of molecule it is? Now, like when you're writing the chemical formula of sodium, we write it as Na because it is a monoatomic molecule. It exists as one atom in a molecule. But when you're writing for some of these gases, for example, hydrogen, oxygen, chlorine, nitrogen, they exist as diatomic gases or diatomic molecules. That means when you're writing it, can have two atoms in a given molecule. Then when you're writing the chemical formula, because you're bringing in the radicals and then you're bringing in the radical and then a given element. So you look at the radical, how does it exist? Now, like when you have hydrogen reacting with water, we have the hydrogen and then the oxide radical. So I hope you can differentiate between those two. The oxide radical exists as O negative, though in most cases we don't include the negative when writing chemical formulas. But when you revisit your table of radicals, you will see that. So you notice that the valency of the oxide radical is at 2. So it will cross over to the hydrogen, and the one of hydrogen will cross over to the oxygen. I don't know whether I've answered your question, Johanna.
I think you have.
Sorry?
I think I've now understood. Thank you.
Petra, you have a question? Petra?
I wanted to ask. I'm confused on the part where exactly we are supposed to where exactly exchanging valencies is needed and where it's not needed. Because here you just said since hydrogen and oxygen are the atomic molecules, we have to put that too. So when you put H2 plus O2 to give you H2O, do you exchange them or like what exactly happens? I just don't know where exactly we are supposed to exchange the valencies and where we are supposed to indicate that we are using the atomic molecules for, yeah.
Okay, Petra. Johanna, your hand is up. You want to answer Petra or you have a question?
I want to answer.
Yes, Jocelyn.
I hope the girls need to note. There's a table that we gave in their notes. And in that table, we get examples of elements that are diatomic. So when you're writing oxygen, hydrogen, and they are alone, like I'm writing oxygen gas, nitrogen gas, then I should be using the diatomic. But when it comes to writing the formula of the product formed after the two have reacted, then you should be using their valencies. For example, when you're writing the formula for water, you're using the valency of oxygen and the valency of hydrogen, not the fact that they are diatomic at that point.
Okay, thank you, Teacher Silver, and I think that was
Could you please
elaborate.
re-explain that?
Anyway, when we get into the next lesson.
Okay, thank you, Teacher Silver. Okay, girls, I think we will have to proceed from there, but please kindly go through those few examples so that by the time we come for the next lesson, we have questions or we recap what you have gone through. Okay, thank you so much, Mr. Bato, for hosting us. Thank you, Mr. Angela, Teacher Silverine, and Mr. Bagams. And thank you, girls, for attending the lesson.